Okay, so we're on 1B.9. 1B.9 is more applications with average rate of change. Okay. And so basically what we were doing with your formative assessment, you were leading into average rate of change. When we were reviewing average rate of change, part example one. Yeah, we're doing example one. Okay. We were reviewing average rate of change by using slope essentially. Now, what makes this average rate of change? So at the top of your paper, it says average rate of change. When we are saying average rate of change, it is still the exact same process. Okay. The official formula for average rate of change is f of b minus f of a divided by b minus a. Okay. Average rate of change applies to all functions. So it applies to all functions. Good luck. Okay. Whereas rate of change is specifically for a linear function. Does that make sense? So average rate of change is for all function models. And as we've discussed before, functions are not always perfectly linear or perfectly quadratic or perfectly exponential, right? And so because of that, we just have to look at it from different, it depends on the interval that you're analyzing, okay? So this is what we're using. So f of b minus f of a is our starting point. All right. So up first here, we have during a snowstorm, Thomas measured the height of the snow in inches and his yard several times over a 12-hour period. He made the following graph with his data set. So I don't know about you guys, but I do have this man in my neighborhood who on our community Facebook page, he does track the weather and lets us know like you have this amount of inches of rain a day and the blah, 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 blah. So I'm, in my mind, Thomas is old because the person that does it in my neighborhood is an old retired man. So I'm assuming Thomas is old. Um, I don't know if that's PC to say, but you know what I mean. So here we go. Thomas measured. So when it started, he was like, oh my God, there was no snow, right? This is over a 12-hour period. Because it's over a 12-hour period, where it's asking us what was the height of snow at 4 p.m. So understanding that this is over a 12-hour period, we are starting from noon to midnight, right? So looking at the snow that's taking place could also be from midnight to noon. It could, right? But because this is our key thing here, is that it's telling us to look at it at 4 p.m. And because it's telling us looking at 4 p.m., we're going to assume that this is midnight to noon. Yeah. Or noon to midnight. What do you want to do? Or noon to midnight. Yeah. I didn't see that. I knew that. Make sure you knew that. Yep. I didn't know that. This is my third year teaching this exact lesson. So it's called sleep needed. All right, here we go. 12. 1, 2, 3, 4. So simply the first question is just make sure you can understand the graph and what you're looking at. So at 4, right here, that is 4 p.m. What is the value at 4? 4 inches. So how do we know? We looked at the graph. We analyzed the graph. We found our input. Our input is our 4 p.m. And our output is 4 inches. There's really nothing to explain there except just making sure that we all understand how to look at the graph. That's part one. Part two is now talking about the average rate of change, okay? So between 6 p.m. and midnight, when we're talking about the average rate of change, we're analyzing boom and boom. So we're looking for f of 6, and we need f of 12 because that's between 6 and midnight. So at f of 6, what do we get? 4. At f of 12, we have 0.5. So average rate of change is your f of b minus your f of a divided by your b minus your a, correct? So when we calculate our a rock, essentially again, it's just a change in your y over the change in your x. So I went to 0.5 minus 4 over 12 minus 6. I do not know why I'm writing in red. Can y'all see that? I mean, I can see it on my paper, but I don't know if you can see it. By paper, I mean computer screen. I don't know if that made it better or worse, but here we go. All right. What do we get? What'd you get? 0.09. Sure. All right, let's open up Sylvie. All right, so we have 0.5 minus 4 divided by 12 minus 6. And I get I get negative 0.583. If you're like me and you like fractions, remember. So either way, but this is what your value is. So I'm a fraction girl. I know that no one's gonna be like, oh, that's what it is. But so we have negative 0.583. And what are our units? So we talked about units for this are the variables of your y over the variables of your x. What are the variables of my y? Inches. And what are the variables of my x? Hours. Okay, so what does that mean is happening outside? It's melting. I'm melting. No one knows what that is? No one knows that movie? Thank you. Oh, someone still is cultured. Yes. The witch. When she's like, I'm melting. Oh. No, melting.
No, not that.
Inches per hour?
Oh, yeah.
Oh, you're good. Always question me. All right. So, how do we feel? Applied it, used it. Now, this function is clearly not perfectly linear, right? We have several functions together. We're going to learn more about that in our next unit, but several functions pieced together is describing what's happening in the real world. And that's how it normally goes. Okay. So what we're going to do is for the next questions, it's essentially going to work like this. You guys are going to have time to work in your group, answer them, and then we're going to come back and kind of go over the whole class. Okay. And that's just generally how this is going to work because I can't stand up here and be the person that tells you this is how you work the problem every single time. These are the type of problems that you have to be able to work through. Okay. And process through. Got it? All right, so we're now on 3 and 4. So using your graph and your group, you're going to do 3 and 4. Okay. On 3, it's asking you over what 2-hour interval on the graph was the height of the snow increasing at the fastest rate and justify your answer. Okay. If you remember our notes from 1B.8, we talked about how your steepness of your line, right? The more steep it is, what does that tell you about it? Okay, that's your little hint there. And then part 4, at what time did the snow stop falling and how do you know? Okay, so I'm going to give you, let's say, 2 minutes and we'll see where we're at after 2 minutes. Okay, go. Okay, so I want you to calculate between 1 and 3. So now find the rate of change and then we're going to come back. Okay, all right. Group 3, what did you guys put for 3? The first 2 hours, so you put from 0 to 2. Okay. Did you guys find the rate of change? Okay. All right. So we have 0 to 2, and they're checking their rate of change. We have group 6 with 1 to 3, and they're checking their rate of change. Did we have any other intervals that we need to compare and contrast? No one else? No other intervals? Okay. So group 6, what did you get for your rate of change? You're changing Y over changing X. So 1 and 2 is only 1 hour interval. And it said, where is the greatest 2 hour interval? So 0 to 2 includes 2. Does that not include 2 though? If I'm going from 0 to 2? So it includes it. Yes. You can see it, but you also could see, you would calculate to confirm. So like when we are looking at a graph, we are trying to, yes, this is our visual analysis, right? What is your mathematical analysis to support your visual? Okay. So what I wanted you guys to do, yes. Yes, it's always correct. Yes, if you were looking at it. So at 0, we're at 0, 0. At 1, we're at 1, 1. At 2, we are at, it's like 2 is like 3.25. Yeah, 3.25. And then someone's at 3, and 3 is at, we're going to say 3.75 because it's not quite at 4. Between, this is 2, this is 3. I didn't leave myself enough room. All right. So if I'm calculating the average rate of change to say this is my consensus, I'm going to have to find those values. So for the first one, from 0 to 2, what's happening? Well, from 0 to 2, I'm at 3.25, right? And then at 0, I'm at 0 over. And that's going to be over 2 because I went from 0 to 2. For the other one, which is from 1 to 3, 1 to 3, I'm going from 3.75 minus 1, right? Over 2. So looking at that, that is going to be my mathematical support there. Okay. So when it says support your answer, this is what we're kind of referring to. So if I'm at 3.25, 3.25 divided by 2. And then I have 3.75 minus 1. I get that divided by 2. Which one is the greatest? 1.625, which is why your 0 to 2 interval is the greatest. Does that make sense? Okay. So visually, you could think, okay, that looks the steepest, but mathematically, that's how you support your analysis. Okay. I hope that made sense. Yes. Okay. So the answer should have been 0 to 2. So if you put 0 to 2, great. If not, now you know. All right. And then obviously 4. What should 4 be? When did it stop falling? So at this point, it's like, and then it's no stop. Okay. So there was no change between 4 and 6. So we're going to say the so must have stopped at 4. Does that make sense? 4 p.m. All right. If you were just to guesstimate on values, average rate of change during that window would have been roughly 2 from 0 to 2. And if you were to look, your constant is telling you that there's no change taking place, right? I'm not melting and I'm not falling, so I must be just chilling. The weather is now holding its own. Okay. All right. Next. So now you're going to, in your group, you're going to read and talk about 5 and 6. Okay. So you're going to read and talk about 5 and 6. Now remember, if you don't agree with someone in your group, tell them why. Don't just accept someone else's answer like, okay. No, you have the right to say, hey, I don't know. Okay. So have those conversations and go. Just you have peers that don't know how to act like they have sense. All right. Should we talk about that? All right, number 5. Let's deal with group 4. Who would like to share? That'd be someone's in it. Which one did you go to? No, that's not the one she was telling you.
It's like literally go that way and past the little office. I'll go downstairs.
All right. Hey, group 4. Okay. Pretty boring. I mean, the general description is the general description. You're right. You're right. That's what happened. All right. What you got, Olin?
The height of the snow reaches 4 inches in between 12 and 4. Then the snow stops and the height stays the same from 4 to 6. Then the snow starts melting and the height decreases from 6 to 4.
All right. There we go. Just analysis, right? We're just describing what's taking place. All right. 6. Let's go with group 2. What was the average rate of change of the height from the snow between 1 and 6? Up to you. From 1 p.m. to 6 p.m. What happened? Who would like to help group 2? Luke, you look motivated to help. Oh. Guys, are we, in all honesty, are we struggling because we don't understand? Are we struggling because we're not processing what it's asking me?
Understand? I just didn't have enough.
I understand.
Oh, on number 6, because anyone did it number 6 in the 2 minutes that we have? Yeah. What did we get? There we go. That's all I need you to do. If you're finding the rate of change, what are your ordered pairs at those points? Change in y over change in x. That is literally all we're doing. Subtracting, dividing. Subtracting, dividing. Okay? Okay? So, there's a full description. But as far as the number 6, the height of the snow increased 3 inches over 5 hours. So the average rate of change would be 3/5 or 0.6 per hour, inches per hour, right? That's all that you were doing. This is the change in your y over the change in your x. And in order to do that, you just have to calculate where your values are. Again, if I'm at 1, that put me at 1, 1. When I'm at 6, 6 is right here. 6 put me at 6, 4. What is 4 minus 1, guys? What is 6 minus 1? That's it. 3/5. Don't know where we're still? I think you guys are overthinking it and want it to be hard, and it's not. Promise you, it is not. You're just subtracting and dividing, okay? All right, so, here we go. Last one. What was the average rate of change of the height of the snow between noon and midnight? So from the beginning to the end, what was the average rate of change from noon to midnight? Okay. You find rate of change, you just need how many points? That's it. Your beginning and that's it. Okay. Then it says, what does it mean if a function? So part A is just making sure you summarize that you understand what it means for a function to be increasing or decreasing in terms of the rate. So I'm assuming we're good. All right. So, and the time went off. So, what was the average rate of change from the height of the snow between noon and midnight? Huh? 124. How do you 124? There we go. Guys, again, average rate of change. All you're doing, my little friends, is identifying your beginning and your end. So for this problem, where do we begin? We end. So 0, 0, and we're at 12 and 0.5. You're changing your y over you're changing your x. If you did anything other than this, then you've decided to make up a whole lesson that I did not teach. Okay, is what you're telling me. As a fraction, that would be 1 over 24, and as a decimal, it would be, there we go. All right, the next part that it asked you is, what does it mean if a function is generally increasing or decreasing over a specified interval, okay? Well, that is referring to its rate of change. If I am increasing, that means I have a positive rate of change, right? If I am decreasing, that means I have a negative rate of change, and that is all that was being sought after. Okay, so if this is still not clicking for you, I'm going to strongly encourage you to make time for tutorial. Okay, if for whatever reason it's not clicking, I'm going to strongly encourage you to make time for tutorial. All right. Otherwise, I don't know how to fix it, but that's going to be my encouragement. Okay. All right. I'm going to stop this. And